your building area, catchment area, multiplied by average annual rainfall, multiplied by runoff coefficient. So rainwater harvesting can be done simply by two techniques, two methods basically you can see. First is storing it in some storage tanks and using it directly, or putting it back into the soil, back into the earth, so that it becomes part of our aquifers, and you can use it later through open wells, through tube wells or bore wells. So this is how you can calculate how much water can be harvested from a building. This is simple arithmetic formula. Have your building area, catchment area, multiplied by average annual rainfall, multiplied by runoff coefficient. So for a city, say roughly having 850 millimeter rainfall, like cities like Hyderabad, you can harvest about more than 70,000 liters from a small house. So this how much water can be harvested depends on what kind of rooftop or paved area or unpaved area catchment is there. And the runoff coefficient varies from 0.2 to 0.9 depending on the type of material, slope, etc. And you get maximum runoff from the roofs and paved areas. These are different components of catchment area, like your roof can be catchment area, your paved area, or even unpaved areas or soil areas can also be catchment. Then there are some pipes or conduits or cutters which carry this water to your rainwater harvesting system. Then you also need a first flushing device, which can discard the initial pollutants coming from the atmosphere, from the catchment area, which may include bird droppings, tree leaves, and any other dust particles, etc. Then you need some filtering system. This filtering system will take care of the pollutants. It will retain all those impurities before the rainwater reaches into your storage tank or the recharge well. So initially, initial rains carries a lot of pollutants. So initial first rainfall, if discarded, then you can store this water and can use it for different purposes. So for a family of even 7 persons, if we consider 200 dry days or the scarcity period where you would have limitations from municipal water supply or your bore well also fails, and if you consider 6 liters per capita per day demand, basically meeting your drinking and cooking requirements, you need roughly 8,400 liters of water. And we just saw that from a building of 100 square meter, we can harvest about 70,000 liters of water. So sufficient water is available for us if we do harvest it properly. There are different types of material, shape, size, etc., through which you can construct these storage tanks. And for recharge wells, you need to dig out in the soil. You need to provide a recharge bore of 4-inch, 6-inch diameter, going up to some depth, say 20 meter, 30 meter, 40 meter, depending on the groundwater levels and depending on the availability of a porous and permeable strata, which will accept a lot of water during the rainy season. And after putting some filtering media, you can divert all this water into earth. There are some examples where rainwater harvesting has been done, and especially through recharge, and the bore wells have been recharged and now they are getting sufficient yields. Apart from individual buildings, this can be done at community level also in a colonies. Like this is example from Panchshilpa colony, where 26 recharge wells were constructed across the colony, and within the stormwater drain you need to disturb the anything, so you can construct these recharge wells or percolation pits inside that drain, and whenever rain comes, these recharge wells or percolation pits will take care of the rainwater for facilitating into the earth. There are some industries which have gone for rainwater harvesting. Is a textile industry in the near Gurgaon. So they need fresh water, and this area is a saline zone. So they were getting tankers from outside. So they decided to go for rainwater harvesting, and they are saving lakhs of rupees on tanker supply, and they are getting best quality water which is available for their processing. and they were able to recover their investment in within 8 years only. And any rainwater harvesting system will serve for 20 to 30 years. So there is a bonus like you get for over a long period of time. So all these designs for rainwater harvesting, either it is tank has less parameters, but recharge structures require some considerations, and all designs are site specific, and they need to consider some parameters like rainfall intensity, how much is the rainfall and what is the intensity, geology and hydrogeology of that locality, and quality of water. So these are other consideration. What kind of aquifers are there? What is the depth of groundwater level? Nature of terrain? What kind of soil or what kind of rocks are there? Geological formation? What kind of monsoon or rainfall is there? All these things can be sourced from some technical persons, and you can design the harvesting system. Now, where to store, where to recharge? When you have more number of rainy days and rainfall is temporarily reduced, like northeastern part of India and southern India, you can go for a storage. And when you don't, when you have availability for domestic and industrial water, like Rajasthan, Gujarat, you can go for rainwater harvesting by storing it and using it. And some places like Bangalore, they charge heavily for municipal water supply. Then also it becomes very practical to store rainwater and use it, so that you can cut down the municipal water supply bill. And recharge, especially when there is a less number of rainy days, so you get rainfall within very short period. So you don't know how to store it in big tanks. Then you can put it back into the earth. And when there is a rapid decline in groundwater levels and aquifers are drying and leading bore wells to give low yield, you can recharge them by groundwater recharging. And especially when the water quality is bad, groundwater quality is bad, then rainwater harvesting can help you in improving the water quality through means of dilution. And finally, when you don't know how what to do with this rainwater, then you can store it. So in Telangana, the development of irrigation or this public water supply is mainly dependent on Godavari and Krishna rivers and its tributaries. There are large number of tanks and ponds, which are important source of water used for irrigation as well as for public water supplies also. There are roughly 46,000 water bodies in Telangana, varying in size and shape. They're sometimes called tanks, ponds, or percolation pits. So these are different types of structure already prevalent in Telangana for recharging. Recharge pits, trenches, shafts in building, premises, open space, parks, and roads. You can also use dry or abundant bore wells, dug wells, or tube wells for converting them into recharge structures. And you can divert all your rooftop water or runoff water into recharge structures. And definitely you need to take care of the open areas, parks, and surface water bodies so that they are able to recharge a lot of water during the rainy season. At household level also, we can play our part in saving the water, because like water saved is water available for future use. So you can either implement rainwater harvesting, you can implement wastewater recycling so that water is used several times before it goes into the drains. And you can also adopt the water efficient fixtures and appliances. You can also check the leakages from your taps, toilets, etc. And you need to quit water wasteful practices. So how can you do it? You can reduce the tank size or flushing time of your toilet commodes. You can install water saving shower sets or low water taps or restrictors. You can turn off your water while brushing your teeth or shaving. Don't let the faucet run while rinsing utensils or cleaning vegetables. You can use automatic washing machines or dishwashers, but don't run them unless they are full load. And while you are irrigating your lawns and pots, do the deep soaking and do it during the cool period, so that most of the water doesn't evaporate back into the atmosphere but is available for root zone. You can plant drought-resistant trees and plants which use less water. Basically, go for native species instead of exotic species. And you can put a layer of mulch around trees and plants so that you can minimize the water evaporation. You can use broom to clean driveways, sideways, and steps instead of running hose for washing as well as for car washing. These are recommendations for municipal corporations or local administrations that they must provide free technical guidance to the interested citizens who wants to implement rainwater harvesting or adopt water conservation measures and practices. And this also needs to be supported by availability of trained manpower, required material, and policies conducive for promotion of water conservation practices. There is also need for water conservation technology demonstration centers, place where people can closely witness the various water conservation technology and motivating interested people to approach local agencies to implement such technologies in their homes and offices. This will require training, education of these professionals, starting from plumbers, masons, engineers, architects, and government officials and other interested individuals, and also engaging local communities in water conservation practices through Jal Chetna Yatras, through exhibitions, through meetings, street plays, engaging students in water clubs, involving people in World Water Day and other important events.